going to talk about special angle relationships. We're going to look at a couple of definitions as well as how to use these in a problem to solve for some values. So we're first going to get some vocabulary in here. So vertical angles are two angles whose sides are opposite rays, and they are across from each other. So if I was to draw a picture of this, I think about vertical angles actually almost more like what happens when two lines intersect. All right, and then we sort of have two sets of opposite angles, or vertical angles, excuse me, every time this happens. So these two angles are one set of vertical angles, right? They're directly across from each other and they share that vertex. And then we have another set over here. So these two are our second set of vertical angles directly across from each other. And again, they share a common vertex. So one thing we want to note, and this is not included in your notes, but it is important, so we're going to add it in, is that vertical angles are congruent. So that means that their measurements are the same. Okay, so that's very important for vertical angles. Okay, adjacent angles are two coplanar angles with a common vertex and a common side. So if we were to draw this, it would essentially be two angles that then when I go to draw the other angle, I only need one more ray. All right, so these two angles right here are adjacent. So we'll highlight that common side, common vertex. Okay, and we often just say that they are next to each other. They're right next to each other. Complementary angles are two angles whose measurements add up to 90 degrees. We say that these two angles are complements of each other. So often I'll remember that complementary is 90 degrees because if you take a C, you can really easily make it a 9 by just dropping a line down there. So complementary angles add up to 90 degrees. So let's draw a little picture on the side of that. If we take a 90-degree angle and we sort of put another ray in the middle there, and let's put our little 90-degree marker, then these two angles make up 90 degrees, and we would say they are complementary. So angle 1 and angle 2 would be complementary. So we also have one of these for 180 degrees. That's supplementary. So supplementary angles are two angles whose measure add up to 180 degrees. We say that they are supplements of each other. All right, so this one, I remember if you take an S, you can draw a little diagonal line and make an 8 for our 180. So let's draw a typical example of what this might look like. So say we have two angles, and they don't have to be adjacent. Nothing's telling us they have to be adjacent. So if I have one angle, and let's say this angle measures 70 degrees, and I have another angle, and let's say this angle measures 110 degrees. Well, 70 plus 110 is 180, so they are supplementary angles. So a linear pair is a special type of supplementary angles. So it's two angles that are supplementary and they are also adjacent. All right, so this is a special one and it takes two of our definitions and puts them together. So oftentimes these angles look like we took a line and we just drew a ray extending out from that line. And then we have two angles, so angle 1 and angle 2 here. And because this is a line, remember a line is sort of like a straight angle, which is 180 degrees. So overall, the total angle is 180 degrees here. Okay, so where are we going to use these? So we want to be able to talk about relationships in different figures. Okay, so we have to fix a little bit of the wording here. So angle 1 and angle 2. Angle 1 and angle 2. That's these guys right here. Okay. We would say that they are complementary angles. The reason being is we have a nice line here, right? Line A. We know it's a line because it's labeled like a line. And then if we have a 90 degree on one side of a line here with that ray coming up, this ray coming up, we know the other side has to be 90 degrees as well. So 1 and 2 make a complementary angle. Angle 1 and angle 2 are also adjacent, but we always pick the name that is the most specific. So complementary tells me that they add up to 90 degrees, and that's way more important than the angles just being next to each other. Okay, angle 1 and angle 5. So let's get rid of some of this. Angle 1 and angle 5. So angle 1 and angle 5. So I always want to eliminate the option of speaking about these angles with regards to their measurements. So complementary, supplementary, linear pair, because they talk about measurements, so 90 or 180 degrees. Those are the ones that we sort of want to use first if we can. But I don't know that 1 and 5 are complementary, right, 90 degrees, and I don't know that they're supplementary either. So all I know is that they are adjacent. They are next to each other. They have this shared ray right here. All right. So next up, we have 1 and 4. Now 1 and 4, we can see are formed by the intersection of these two lines. They are directly across from each other. So this is what we would call vertical angles. So vertical angles are formed by almost two V's, right? It's a good way to remember it. All right. So let's take a look at our last one on here. Angle ABC. ABC. So that's this whole angle. A to B and then out to C. And angle 4 are what type of angle? So the first thing we want to know is that if we go across both angles, right, we hit the other side of a line. So we start from kind of, if we consider this opposite rays, we kind of start on one side of that vertex and we go all the way to the other, and that's our line. So we know that this is 180 degrees because that's a straight angle right there. But there's something more, right? Because these two angles are adjacent. They share this side, BC, ray BC. So if they're adjacent and supplementary, then we call them a linear pair. So they are supplementary and adjacent. So we call them a linear pair. And this is the name that's important, the linear pair. That's what we want to know. So we want to use these in a problem to solve for some values. All right, so I'm looking at this problem, and it's saying that we want to find x and y. All right, so first thing I'm going to note is that angle ABC, this angle right here, angle ABC, and angle CBD are supplementary angles. So we know that when we add them together, we get 180 degrees. So I'm just going to write that down and apply it. And we want to adjust our notation. because now we're going to start talking about measurement. So if I take the measurement of angle ABC and I add it to the measurement of angle CBD, I'm going to have 180 degrees. So let's substitute that in. 3x minus 5 plus 7x plus 10 needs to equal 180 degrees. So let's solve that. If we combine like terms, we would get 10x plus 5 equals 180. Subtract x from both sides. Subtract 5 from both sides, and we would get 10x equals 175. Divide both sides by 10, and we find that x equals 17.5. Okay. Now we want to keep going because we still want to find y, right? We found x, but we still want to find y. So something that we're going to note is that we have two vertical angles. Okay, so we're going to go back up to our figure. And we know that angle CBD and angle ABE are vertical. And the special thing about vertical angles is that they are congruent, right? That's very important. So vertical angles are congruent. So we have angle CBD and angle ABE. We said they're vertical. That's very important. So they must be congruent. So if they're congruent, that means their measure is equal. So the measurement of angle CBD and the measurement of angle ABE are equal to each other. So let's substitute in and use this. Now, if I'm looking at angle CBD, currently it says that's 7x plus 10, but I'm using this to find y. I don't want to have an x in an equation that I'm using to solve for y. So what can we do? Well, we just found x. So instead of using the expression with x, let's solve real quick to say that the measure of angle CBD equals 7 times 17.5 plus 10. So this way we're getting rid of that x and we're putting in an actual value. All right, and we're going to get 132.5 degrees. Okay, so now I'm going to put that in here. So 132.5 is going to need to equal our ABE, which was 5y plus 4. Okay, so if I had that x there, we would run into a problem because we can't solve a single equation with two variables. So let's solve for x, subtracting 4 from both sides. We would go ahead and get that, and I'm going to go ahead and rewrite this a little bit as 5y equals 132.5 minus 4 is 128.5. Divide both sides by 5, and we get that y equals 25.7. All right, now that is not a degree measurement. That is the value of the variable, but not the degree measurement of the angle. If we wanted to find the degree measurement of the angle, we have to go back up here and we can plug that in 5 times 25.7 plus 4 to figure out what the degree of that angle actually is.